I'm Cristhian Deagustini, although people know me by my middle name, Ariel, and I'm giving you a brief introduction in our paper, Belief-Based Contraction by Accrual, that was published last year at AFJ. So the paper verses on a problem that we have seen on recent talks is how we contract a formula from a knowledge base so it no longer entailed by the knowledge base. Most known approaches to this task involve flat knowledge bases in the sense that there is no additional information about the formulas in it. In particular, kernel contraction by Sven Hanson is a general approach contraction that tells you that you need to remove at least one formula from each minimal set that entails the formula alpha that we are trying to contract. But it doesn't tell you how to choose which particular formulas will be removed. What we propose here is to exploit additional information if we have about the formulas, so we can avoid unintuitive outcomes and provide optimal constructions with respect to that additional information that we call features in our work. So this, consider the following scenario. Suppose that we are a student and we are trying to decide which courses we will take next year. And we want to do that by optimizing the amount of academic credit that we get. Now, suppose that I tell you that you need to choose between algebra and logic because those courses cannot be taken at the same time, and that algebra gives you 10 academic points, while logic gives you 6 academic points. Then your natural decision would be to remove logic from that conflict, from that kernel, and retain algebra, so you get 10 academic points instead of 6. Now, same thing happens here in another kernel between algebra and stats. We end up in this situation where we have removed logic from kernel 1 and stat from kernel 2 and retained algebra, getting 10 academic points, which clearly is not the most intuitive outcome, because we can do this instead. We can retain both logic and stats and delete algebra, so we end up with 12 academic points instead of 10. What happened here is that, in a sense, logic and stats are teaming up against algebra, and they do that by accruing their values, their academic credit in this example. Well, that's the kind of behavior that we are trying to formalize in our paper. I will briefly go over the results that we have gotten. First, we have proposed a novel design for contraction operation that works with this augmented knowledge base where we have that additional information about formulas like in this example, academic rate. And they do that by accruing the additional information. We have characterized those operators to postulates, and we have presented complete constructions for 2 different families of operators, one that looks into the complete KB when it's performing the contraction, and one that only needs to look into particular subsets of the original knowledge base. And in particular, we have shown that both approaches obtain the best valued KB in the light of the features that we are considering in our application domain, for instance, academic credit in the example. Well, what are the main perks, in our opinion, for our work? Well, the model itself is domain agnostic and modular, so you only need to provide two key elements, and then you are good to go to apply the operators. You first need to establish which are the features that interest you. For instance, how reliable a formula is, or the academic rate in the example. And you also need to provide a way to accrue the values or a particular accrual function that can be, for instance, addition, like we just saw in the example. And those choices can be made independent from one another, as long as they make sense from a semantic point of view for the scenario that we are presenting. So we end up with operators that can be applied to any scenario where those 2 elements can be defined, And the thing is that we can be sure that those contractions made are optimal in the light of set choices of that set of interest and accrual functions. That's what I wanted to show you. I thank you for the time, and I'm open to answer your questions. Thanks.